Okay, thank you all. I want to tell you a story. This is a story about a plucky young developer excited on his first project. He's skipping through the fields. It was lovely. There were lots of squirrels around. It was in the trees. The squirrels were merry. Anything was possible. You imagine all these towering abstractions, and they're limited only by his own imagination. So he set to work, producing mountains of code, having so much fun, just cranking it out. It's awesome. And then, hang on, what the hell? Hang on, just a second. That's not supposed to happen. No method error. Huh. Okay, let's do, that'll be fine. Anyway, that should be okay. So he was skipping, and the squirrels were merry. And the project launched, and everyone thought it was pretty good. He went on to more projects, more code, and he traveled the world, and he went on to work with bigger things, bigger teams. Again, crap. That should be okay. What's wrong there? Hang on, sorry. Hang on. Yeah. Double equals. It's embarrassing. There's like 2 minutes of my life I'm never getting back. And before long, he was in charge of his own projects with his own team. And things were getting more interesting. Lots of data, lots of code, and so many chances to do so many wonderful things. And this was with the help of new and amazing colleagues. And this just kept on getting better and better, and then it's again, okay, what the hell? I already fixed this. I don't know what's going on. No method error. Concurrency. Race conditions. This is like a 1 in a million chance it'll ever happen again. I'll just keep running it. The code runs like 1 billion times a day, but it won't happen again. So things are getting tougher for our plucky young developer. And he's not so young and experienced anymore. He's started to believe himself a little bit invincible now. He's been around the block a few times, figured out what's going on. Possibilities that he'd imagined when he first started out as a young, plucky developer, he'd kind of done a lot of them. But more lay ahead, bigger things, cooler things, more awesome. The enormity of that task is starting to sink in. That's the enormity of the task sinking in. Yeah, don't do this with active model, active record. Do that, it's better. Dumb. The hours got longer, the demands got higher. Multiple clients, multiple projects, having to juggle these things, all while keeping an eye on the team. Reviewing code, still needing to be hands-on because this dreaded, lurking fear of becoming post-technical. Okay, now what? Drop table students. Okay, don't do that. Don't do that either. No comment. The day I learned about time zones. I seriously wasted 10 years of my life because of this book. So things got much harder, and they took longer. There's starting to be anxiety about small things because there's so many of these bugs going on. Code changes that once seemed really trivial are now hard. It's like this lurking sense of dread. I know. The 80-hour weeks soon became the norm, and the code didn't come out any faster. Anxiety is getting worse, more and more there. It's not just a feeling anymore, it's actually this constant background hum that's sitting there. And it got hard to work. Progress got slow. The developer's getting older, a bit more cynical, feeling pretty burnt out by it. In the end, our developer hit a wall, completely burnt out. This constant anxiety and panic attacks were now the new normal. It took a few months to recover. A bit of time, taking it slow, getting back to something vaguely human. Lots of talking, worked out enough to carry on. The anxiety is still there. I'm not even using JavaScript. Come on, give me a break here. It sneaks in everywhere. I don't know. So let's take a moment here. If this is you, it sounds familiar, there's some things you can do about it. First of all, hit Google. That'll give you a lot of results. I'm serious, like actually pretty much the first page of Google for anxiety is good resources. Stuff like Beyond Blue, Limbo that Pat was talking about before, which sounds awesome. If you don't think you needed help, you probably do. Talk to someone, especially a GP, because they're really good. Despite successive governments, Medicare is still all right. They can refer you on to someone, exercise, meditate, see friends and family. Just take care of yourself. Anyway, moving on. That's the mental health part of the talk. So this is kind of how new developers see the world. It's like the green, awesome, unlimited, infinite field of possibilities. It's like the Windows XP desktop wallpaper. So it's kind of how I did it anyway. And it's unlimited. You can do anything. Once you figure out this coding thing, there's so much stuff you can do. But it's kind of dangerous as hell, and you don't even know it. This is how experienced developers see the world. So like this hostile war zone. And there's all kind of danger lurking. There's danger there. There's landmines, barbed wire, machine guns. You build up a lot of scar tissue to this stuff. You've learned to be careful from lots and lots of painful mistakes. Probably a little bit paranoid. You don't need to think of it like this way, but a lot of people do. So both of those worlds are hard to work in. Neither of them are really very productive. What we really want to get to is something like this. This is like a working farm field, It's not a dreamscape of youthful, boundless fun. You're not going to be skipping around here merrily, but it's not a nightmare battlefield either. Like, you don't have to worry about landmines. It's a productive place. It's a real place. The difference between those two is fear, for better or worse. So let's go back a few 100,000 years. And you're a prehistoric human walking past the waterhole, and you see a lion by the bushes. And all animals experience fear. You get a rush of adrenaline from this. Increased breathing and heart rate, and there's buzz, you get a sense of clarity and focus, and your physical performance is enhanced. You can run. It's triggering your fight or flight reflex. There's a real bias towards action. This is a good thing because it helps you survive if there's a lie there. The other side of that humans have, because we're kind of cursed with higher level thought, we walk past the waterhole and there's some grass there, and we saw a lion in the grass last week. And our imagination kicks in. What if there's a lion there again? We're anticipating the future, we're planning. But the fight or flight reflex gets triggered again, even though there's no lion there. And often this is still sensible. There's a survival instinct, it's actually a good thing. There's no short-term buzz from that, and it's a horrible feeling, especially if it's long-term. But the difference is it gives you a bias towards preventative behavior rather than action. Go to the modern world, this is kind of similar. If you've ever been in a production outage, that's sort of what it's like as well. It's a strong fear response. There's a sense of clarity, sense of focus, bias towards action. It helps you get through that. And actually, humans are really good in this environment. You get 5 people in a room who know what they're doing with a critical thing that has to be fixed. It gets done really well, really quickly. But anxiety is obviously a very modern thing as well. There's a fight or flight reflex gets triggered there, but there's nothing to fight. There's just things that might go wrong. And the complexity of modern programming means there's so many things that can go wrong. So it can give you some analysis paralysis, and you can't think. Humans are not well suited to this kind of functioning. The doors and corners, that's where they always get you. So what this really has an impact on is working memory. And working memory is the space and cognition that you have to work on a task. The greater your working memory, the more complicated a thing you can manage. It's kind of sort of how smart you are. It's related to that. You might have heard of the 7 plus or minus 2 things that you can keep in memory. It's a little bit more complicated than that. It's like a theory from the 1950s, but it's roughly that. It's a number of chunks of things you can keep in memory at once. But that reduces temporarily when you're under stress. And if you're under chronic anxiety, it'll reduce for a longer period of time. And thinking about all the danger zones in your code kind of has that effect of reducing your working memory, reducing your cognitive ability. There's dangers always flitting in and out of working memory. But the core thing you're trying to do gets crowded out by all these other things. The best way to optimize that is to stop needing to put things in there. So let's go forward a few 100,000 years ago. Ancient Sumeria, what's now Iran and Iraq. About 6,000 years ago, lions aren't a threat to people anymore, but they're eating our sheep. And we want to keep track of how many sheep we lose. So we use clay tokens to keep track of this. And they're easy to understand. It's a very mechanical thing. We've got one there that's 5 sheep and another one's 3, just kind of put them together. But it's very mechanical. You've got these stones on the ground, and you can mess this up. The sheep walks through your stones, and I don't know how many sheep I have. The sheep's in the way. Physically shuffling around gets very error-prone. So it means if you want to recount, you have to put them all back the way they were. You have to do it exactly right. And it's a little bit tricky. It doesn't work very well. Go forward a little bit further. Ancient Babylonia, 3,500 years ago. Got written numbers that have been invented. Arithmetic had been invented. And it's removed the concrete physical work, mechanical work. There's no shuffling of tokens anymore. We've actually got a thing that is abstract and easier to reason about. It's immutable, stateless. It's an expression of facts rather than being just a lump of physical things you move. And you can repeat this work from a known state, give lots of information that you can go back to and see your working where it got to. And you can copy this and then expand on it. And modern numbers in math are really just an extension of that system. So think of this here. We've got 27 sheep, we lose 3. How many do we have? We have 24 sheep. This is very easy to reason about. This is totally immutable. You can't accidentally have a sheep walk through your 27 and it becomes something else. It's pure, stateless, repeatable. There's no mechanical moving parts in any of this. It's not imperative, and you can't stuff this up. You can, but if you do stuff it up, it's actually pretty easy to figure out where and how you stuffed up. And someone else looking at that can find out where you stuffed up. And that's what functional programming really is. That's the guts of it. There's less to think about, less to go wrong. Shuffle the stones, things get messed up. You do maths, things don't really go wrong. So that reduces anxiety. You don't have to think about it, which means you've got less in your working memory, which means you get more done because you don't have to keep track of all this other stuff. It might break. But Ruby, right? Sometimes when I'm doing Ruby, I feel like a kid there. Like you're doing something blatantly unsafe and pretty inefficient. It doesn't make a whole lot of sense. But you need a huge amount of supporting infrastructure just to make it halfway plausible so that you can actually even pull this off. But Ruby's got some pretty good tools in there to make functional programming work. Ruby was kind of my functional programming gateway drug because I was learning Ruby and Erlang about the same time and reading all the stuff in Erlang about functional transformations and things at the same time as reading about map and inject coming from Ruby. So you have to take advantage of this in Ruby where you can, because there are bits in there that are really useful. But you have to realize it's never going to be pure functional programming in something like Haskell, for instance. We can try. The functional programming is not that complicated. It's just a few things. Values, these are simple things everyone knows. You've got numbers, you've got strings, objects, whatever. It's data. Functions, which are just things that don't use at variables, is kind of the easiest way to talk about that. Just arguments. So you have things that pass in, arguments, you do some things, you pass a value out. Easy to reason about, there's fewer moving parts in there. John Carmack has got the right idea about this. He had me blasting Nazis when I was a teenager, and demons, and people on the internet. He's all right. I like John Carmack. So the thing about functions, they have to be pure functions. That's a very special thing. Same inputs every time give you the same outputs. There's no non-deterministic behavior in there. It doesn't rely on any external state. So there's no preconditions that change behavior. The function itself doesn't change anything of the state of the context it's operating in. Nothing can go wrong there, but you don't mutate arguments as well. Don't mutate arguments. If you mutate arguments, we can't be friends. So this is great, like pure functions, I love them because it means when I see a pure function, I don't have to think about anything. I don't have to clutter my working memory with stuff. I can just keep it, think about what is the code doing right in front of me. Local variables, arguments get passed in, value gets passed out. One of the important things as part of that is immutability. You don't change objects after you create them. Create a new object, copy state over, use persistent data structures, it'll do that for you. Talk a little bit more about that later. So here's an example of that. So we've got a very simple class here that is keeping a flock of sheep. So we have a flock size, and we've got an eat method that says, okay, here's how many sheep that got eaten. And instead of actually having like a number in there, like a flock size that we mutate, we just create a new flock with that number changed. So it means down bottom here, we can create a flock with 27 sheep, eat 3. The original one still has 27 sheep, but our new one has 24. So we've kind of got like a history, like a snapshot of all the states that this thing's gone through. So if you do event sourcing or any of those kind of things, this is very useful for that. So you can write your own custom Ruby code to do that. And there's a whole bunch of gems out there that do it as well. Amsterdam is one that's pretty cool. This is a way of just having an immutable persistent struct. And the persistent has got a very specific term that means you don't copy the entire huge object graph. You just copy the bits that have changed, and then you have a reference back pointing to the other ones. It means they're very efficient internally. It's the same sort of thing. We're just defining an eat method that gives you a new flock size. So that set flock size there just creates a new flock with a different size in it. We've still got the old one. It hasn't changed at all. Algebraic is another library that I love. It's awesome. It gives you things that sort of look like Haskell types in a very weird way in Ruby. Works pretty well. The weird thing with these things, they don't give you a way to actually define methods on the types that you create. Like you have to open up the module and put another method in there. But it's the same thing. We've got an eat method on our flock, and that just changes. Well, it doesn't change. It gives you a new flock with a new flock size, so you can go back in and not mutate anything. Hamster is another one that's awesome for collections. Simon Harris, I don't know if he's around, but he's like a Melbourne guy that kind of puts stuff together. He's on the Envato table out front. Go and talk to him. We're hiring. Yeah, so Hamster just lets you have immutable collections, so hashes, vectors, lists, sets, and it means that it gives you a very efficient way of creating a new instance of a thing with only like part of it change with a reference back to the original part, so you haven't actually taken up too much. And there's all the awesome stuff from Dry, like Tim was talking about this morning. There's a whole bunch of other libraries out there as well. The immutability is a very important thing. Don't have to worry about code changing variables or another thread changing a variable under you. You can take for granted that you have a variable that never changes. It's easy to reason about. But the really big ticket one is statelessness. Immutability is cool, but you want to have statelessness. So this is the big difference between immutable, imperative, like traditional OO you get in Ruby, and functional languages. This is kind of moving the pebbles around when you do it statefully. If a sheep walks through that flock class and disturbs the flock size, then you don't know what's going on. Encapsulation helps with this, and that's a good OO pattern, but sometimes you just don't need the state at all. Like have a function that just says, here's the things that come in, we do a transformation on it, here's the new value that comes out. And you can chain these functions together as well. Like you don't have to just have a function that stores state, gets passed around. You don't always need an object. So if you try and think of a world that has no variables whatsoever, just expressions and functions that transform them, it's very easy to reason about. So if all you remember today, 90% of the benefits of functional programming you can get by just having pure functions, immutability, and statelessness. Once you get those things, you're 90% of the way there. There's a whole bunch of other cool stuff like monoids and stuff, which are kind of nice, but they're not that required. So if you're living in Ruby world, enumerable is your friend. Array and that sort of class inside Ruby are all implemented in terms of enumerable. And all you have to do is implement each, and you get everything else for free. It looks kind of like that. That's all you have to do. So you just include enumerable. You define an each method, and you just yield stuff out of it. So you can implement it by hand like that if you want. You wouldn't do that very often. You usually just delegate to array or something like that. But the cool thing you do if you use enumerable is you get map and inject for free. So these are things that are on hash and array, various other Ruby core library classes. They're kind of your bread and butter. You can do everything with these, like 90% of what you want to do. So map is nice. It's an immutable functional transformation. This is a higher order function. So a higher order function is just a function that takes another function as its input and does something with it. So a block is a function in Ruby. That's really all it is. Anything that takes a block is a higher order function. So this is an example of also what you call a functor, which I won't quite go into that, but Ruby doesn't do it quite consistently. So it's still very useful. Inject is very cool too. So inject lets you take a big thing like an array and squash it down to some value. So the example here, we're just taking an array of numbers and we're using an accumulator to add each item in general. Then you pass the accumulator back out of the block and you squash them together. And Mel did an awesome post on this last week on Twitter's. So going through this one here, we're really just saying, taking 1, 2, 3, 4, starting with 0, and then you add 1 to that, you get 1, you add 2 to that, and you get 2, add 3, and you get 6, then you add 4, and you get 10. The nice thing about that is that that is entirely immutable, it's entirely stateless. And this is just using pure functions. So even though you implement enumerable using each, don't use each. Each by nature just requires you to mutate. So you have to change something if you use each to actually do any useful work. And each with object. This is a discussion last week with Andy Snow and Phil Arndt, who's around somewhere. He's got to talk tomorrow, so he can rebuff me on this. Yeah, basically each with object, you have to get an object yielded each time that you have to mutate. So you have to here's the thing, I'm going to keep mutating it every run through. So map and inject will do 90% of the transformations that you want. But Ruby, performance is probably going to suck. Sometimes, not all the time. Lots of object allocation. If you're constantly creating new copies of things, running through, you're going to have a lot of objects being created. There's an overhead for that. Lots of data copying, lots of garbage collection overhead, and it can slow you down. So if you do have that happen, benchmark it, because maybe it doesn't suck. Maybe you've just looked at the code and you think it sucks, but it's actually okay. Try Hamster, which is an awesome library. Thanks, Simon. And use imperative mutable code when you need to, but minimize it. Here's another one that was on the ViewSource Slack Ruby community. I don't know if Dylan Lacey's around somewhere. No. He was saying he might smuggle in some alcohol to RubyConf, and Michael Pearson, who's not here, saying that would be good because that'll help him get through the 5 or 6 functional programming talks. There's an next bit here, you might need it. So if you're sitting by Dylan, just share the love. I'm going to go a little bit deeper into this. So there's lots and lots of functional data structures, like algebraic data types and awesome things you can do. I'd love to go over lots of them, but we've only got 40 minutes, so I'm not going to. Monoids are one that I'm going to talk about. So these are monoids, not monads, totally different thing. Monad's just a monoid in the category of endofunctors, so what's the problem? You already know monoids, so if you can add numbers together, they're a thing that lets you add with a binary operator that combines 2 things. So 1 plus 2 equals 3, that's a monoid, because you just got a plus that combines 2 things to give you another thing back. I've got an identity, which is 0 in this case, and that means that if you combine that identity with anything else, it doesn't change anything. And the order doesn't matter either, it's associative. So if you add 1 and 2 together, then add 3, it's the same as adding 1 and then 2 and 3. That's really useful because it means if you want to do that in a multi-threaded situation, you can actually split that up and run it that way. They're also from Doctor Who. Don't know if anyone's familiar with the first Doctor Who from like 1966, but they were like one of the enemies. The Weeping Angels have got nothing on these guys. So the monoids have a lot of laws, or 3 actually. There's a binary operator to combine them, which is plus in the case of integer addition. There's an identity element that doesn't change anything, which is 0. And they're associatives. You can change the order that you actually apply that thing that puts them together. So this counts for a lot of different data structures. Arrays are monoids, hashes are monoids. If you use merge, it works exactly the same way. And objects can be monoids too. So here's an example of a big flock that's got a shepherds. This is using algebraic again. And then you have shepherds, and you have a flock size. And it's got 2 things. So there's mempty, which is a term stolen from Haskell, which says a big flock is just an empty version of a thing. That's the identity. So it's a big flock with no shepherds and 0 sheep. And mappend, which is also stolen from Haskell, is when you just combine them together. So the thing about this is that you can take those flocks and have multiple of them, put them together, and you get one big one at the end. Why do we actually care about this? This is like a fairly simple thing, you're just adding stuff. It's an immutable, pure, stateless way of combining stuff. That's all the cool stuff about functional programming, all the benefits of it. But it's also a general, reusable pattern. It's really useful. Less to think about, less to go wrong. You don't have to keep the stuff in your working memory. It reduces your anxiety. Go through a really quick example of a shopping cart done this way. So this is kind of a big one. Got a shopping cart that has got a bunch of items in it, created at, updated at. What we have to do with the shopping cart is to handle the case where the user's not logged in, or let's say the user is logged in, they add a bunch of stuff to their shopping cart, then they go away, they come back on their phone or something, and then they add a bunch of stuff when they're not logged in. We want to take those 2 things and squash them together to actually have the full list when the user logs back in of what they want to buy when they check out. So we're using a monoid again here to do this. So we've got an mempty function that just gives an empty shopping cart, but we recursively go down through our object graph. So we've got a sum value hash, which I'll come back to in a minute, but basically we take the empty thing of that. We've got a created at date, which is a minimum date time. We take the empty of that, updated as an empty as well. Then when we append them together, we get our shopping cart, and we take the items, append them, we take the created at, append it, updated at, append it. We've also got a helper there to put a value into that shopping cart as well. So if you've got integers and you want to add the integers together, you probably shouldn't monkey patch things because everyone will hate you if you do stuff like this. Don't monkey patch integer. Two reasons for that. One is that monkey patching classes is pretty horrible. The other one is that there's multiple ways that you could actually apply a monoid to a class. For integers, you can plus and you can multiply, and they both have different behavior. So what we want to do is wrap it in a monoid type. We'll call it a sum, and our empty is a 0, and our append just takes the value from one, gets the value from the other one, adds them together. So 1 plus 2. How do we combine dates? There's some rules here. If you've got sort of specific business logic you want to implement, you may have to actually dig in and say, if it's this field, we want to combine them so that's lowest, that's highest. If you've got a created at date, you want to take the earliest created at date. If you've got an updated at, you want to take the latest updated at when you combine these two shopping carts together. So you can do both, which is why we have a minimum date time, which our empty is like way out to infinity. And when we append it together, we just take the minimum of these two things. The reason we have the empty way out at an infinity is that we can combine it with anything else and you'll get the other one. Max is exactly the same except max instead of min. And our sum value hash is just a thing that will, put one of those values into there. A sum value. So the user signs in, puts the stuff in the shopping cart. We get a shopping cart, which is empty. Then we update the created at, update the updated at, add some cheese, bread, milk. Then the user goes away, comes back a little bit later, maybe on their phone, signed in, they do some other stuff. Okay, cool. So now we've got two shopping carts for this user. Logs in again, session's retrieved, we've got to put the carts together. This is kind of where the payoff is. This is the bit that I love, because we're taking the signed in shopping cart that was created first, the signed out shopping cart, put them together. We don't have to actually implement any custom logic here. We're letting the types do all the work for us. There's no state being mutated. We're just functionally taking things immutably, statelessly, putting them together with pure functions. So you don't need any complicated logics for this. You're just recursively using those same functions all the way down. So mutable objects that can be appended together sounds a lot like inject. So that's kind of all it is, like supercharged inject. You take all the carts, inject, start with the empty shopping cart, then you just append each shopping cart in order, which is kind of cool. Don't actually do any of the stuff though. The ideas are useful. You don't actually need to implement full-on monoids or algebraic types. The ideas are useful. So look at common ways you can isolate patterns. Look for laws and simplify rather than adding special cases. So we've got those monoid laws. We've got associativity, left identity, right identity. Laws in mathematics and science are different to laws. Like if you have a law, which is like you can't turn right at this intersection, that says something you can't do. That's not what a law in maths or science means. They're just a thing that are. So we've got Isaac Newton. He came up with a bunch of laws about force and motion. So he said an object remains at rest unless the force is acting on it. If you apply a force, it'll accelerate. And for every action, there's an equal and opposite reaction. They're laws of motion. He didn't invent those. They're just things that are. He elegantly described what is real. This is reality. This lets us better reason about all those things. And functional programming is exactly like that. So that whole sort of example about monoids there means that these are the laws about monoids. They're not legal laws. They're not like an API or a specification or an interface. These are just natural things. If a thing does these things, then it is that. And it lets us reason about them. Once we identify those patterns, we can put them together in that way. They're utterly simple, but they're also generally useful and elegant. So monoids are just the tip of the iceberg for this style of thinking. Got other functional algebraic data types like functors, applicatives, monads, that magical word again, everyone loves it. But by thinking in terms of laws and expressions, you can reduce them down to a simpler task, reduce your cognitive load. Makes the coding easier. So everything else in there, pure functions, mutability, statelessness, lets us treat things as laws. There's less to think about, less to go wrong. You get the special cases, get them out of the way. Weird errors, weird boundary conditions, get them out of your head. What you're really trying to do is unload your working memory. So you don't have to have the stuff in there. just have the type system, or you have the functional composition, putting things together in a way that actually makes sense, and then you can work with it from there. We do this so we can reduce our anxiety. There's no line in that grass because we've kind of made it impossible for there to be a line. We've defined laws that say lines will never be there. We've identified that pattern. And that means we're able to do more. And thank you.
Cool. Well, we might do some Q&A because you ended a little early, which is great. Which means for the first time today, we can actually do Q&A. So if you have some questions for Julian, go on to the Event Fuel app and comment on his talk. So let's see. That's actually fairly funny. Existential question, if a variable never varies, is it still a variable?
It's probably a value.
There's lots of comments saying how great your talk was, so that's nice.
Thank you.
If anyone actually does have any questions, that would be great. Because then we don't have to vamp on stage. And because, I mean, your talk looked great. The slides are great. I didn't understand a word you were saying. Sorry? Excellent. Explain your production experience with Elixir and gotchas. No, it's not yours.
Elixir and gotchas. I don't have a whole lot of Elixir production experience, which kind of sucks, because I was working at Envato and I said, Elixir's awesome, we should be using Elixir for a lot of stuff. And people said, yeah, that sounds kind of cool. And then I left Envato and everyone started doing it. And then I sort of went off and did some other jobs for 6 months at Huru, where Mel is now. And then came back to Envato again, and by that time everyone was doing Elixir, but I wasn't on those teams. So...
And I think Huru's going to use Elixir to rewrite Billy.
Cool. So that push that I was doing when I was at Huru, that's paid off too when I'm not there. So there's a pattern going on here. That could be a law. But from what I understand, like, it's actually fairly good in production. It's kind of designed, like the whole marketing spiel is it's based on the Erlang VM, and that's basically designed for reliability from the ground up. Compared to Ruby, it's generally pretty low overhead, pretty low maintenance. It just kind of keeps running.
Joshua Paling's question. Vars, flock, and flock2 is okay, but in practice I get increasingly long and awkward to name. The app just like jumped randomly to somewhere else.
No.
All right, no.
It's all good. Just you're putting in questions and it's updating the app as we're going, which is great. Keep asking questions.
Just not so quickly. Vars, flock, and flock2 is okay. But in practice, I get increasingly long and awkward to name variables when writing functional code. With each applied function transformation, the result gets assigned to a variable which must have a unique name. Do you have tips for naming things when writing functional code?
Yeah, if you go like deep into like that whole way of doing things, you get into like functors and applicatives that kind of clean up a lot of that stuff. If you're just doing straight functional programming where you have here is a variable, and then you call a function and assign it to a variable, and you pass it to another function and another function. If you're doing that stuff by hand, it gets messy. Exactly what ways to get around that, I'm not sure. It depends on what the code was and what it looked like, I guess. But there are deeper functional patterns that let you solve a lot of those code smells.
Cool. What is statelessness and immutability?
Statelessness and immutability. So immutability is when you don't change something. So you create an object, and instead of changing that object to have a new state, so say I've got like talked about a flock of sheep, and it's got a count in there as an instance variable to say I've got 27 sheep. I'm going to say I've now got 24 sheep. Instead of changing that instance variable and actually keeping the same object, you create a new object with a new value for that count. So you're not actually changing the original, you're creating a copy of it with just the things that have changed being different in the new copy of that object. Statelessness is when you don't have any state, so you don't have anything outside the context of the function that your function relies on. So things like instance variables, use them when they make sense, but a lot of the time you don't need to. You can just have here's a value that I've got the inputs that go in, and then you do something, you do a transformation on those to calculate a new result, and then you can pass that result to another function. So you don't actually need to store it anywhere. You can just kind of pass results from function to function.
Why shouldn't we use some of the techniques you mentioned?
You can. You totally can. I haven't tested any of those in production. They kind of make sense in theory. I've done some of the similar kind of things, but more, conventional Ruby. People aren't going to understand it necessarily. So you can do the stuff, write a lot of documentation, and talk a lot to your team, because if you're in a larger team and you launch this on everyone, you might not be that popular.
Do you have any examples of functional patterns being deployed in OO systems, e.g. a Rails app? How big a problem do you recommend picking to experiment with these tools?
So in the experience like at Envato, a lot of the systems we're using are event source systems, and a lot of these patterns make a lot of sense there. So they're not traditional Rails apps. In fact, I don't think it uses Rails at all. Your guy does it. He knows all about it. Liam knows about it.
Only because Sebastian talks about it almost constantly.
Sebastian talks about it. He does that at work too.
I'm so sorry.
But a lot of these patterns make sense there. Like if you're doing event sourcing where you've got a stream of events coming in, you don't ever change those events. Those events are immutable. And then you're just applying a transformation to maybe emit a new event as a result of one coming in, or you're just creating a projection that sort of says, okay, I'm going to take that, do a thing, do a thing, do a thing. There it makes a lot of sense, huge amount of sense. In a traditional Rails app, you can do it in the small, like in the scope of responding to a request inside a controller. That makes a lot of sense. There's also a lot of work around, not using active record at all, because active record's kind of the opposite of all of this stuff. If you can have just value objects that work with data, and then you isolate the edges of your system, so the I/O happens just at the start, at the end, and then you have a functional core in the middle, that's when it makes a lot of sense.
Whoa, we just got a ton of comments. Ruby's not designed as an immutable language. How far do you think we should go with immutability?
As far as it makes sense, like if it's useful, do it. If it doesn't make sense and it's painful, don't do it. So one of the comments we had at Envato when I was going through this talk is like someone had come across a system. It was actually like a JavaScript React system that was using immutable JS. And he sort of said it was hard to understand exactly what that code was. And I apologize because I put that code in there. But it's basically, if it's a core domain thing, like if you've used Redux, or a lot of those JavaScript patterns are going to that way of working with it. Like if it's your core domain the way through, it makes sense. But if it's just bits and pieces, it doesn't make a lot of sense.
Do you feel the changes you've made in your coding style have helped your mental health as much as the things you listed at the start?
I discovered functional programming and everything was better. No, I mean, it's not a huge difference really. It's a way of thinking about things, because I sort of did find that, the way of when I was younger, you could just have huge amounts of stuff floating around in your head and you could kind of tie it all together. I just can't do that when I'm getting older. So I sort of need a way to keep things straighter and more lined up so I can get my head around them.
Definitely gives you more control over things, at least.
Yeah, that's the thing. It's about control. It's like getting rid of all the edge cases and the problems. So you sort of draw a line and say, these things are totally outside of the scope. We've logically ruled out that these things over here can never happen. I'm just focused on this little bit down here.
Last question. What would you recommend to get started practicing these techniques?
Elixir. Yeah, I mean, Elixir is actually like a really close. It looks almost the same as Ruby. If you squint, the syntax is identical. As soon as you get anything under the surface, it's totally different, and that's okay. But it'll kind of like, it's an easy way to nudge into it, and especially the way it treats immutable structs and the way that they get maintained and updated is very applicable. Because libraries like Algebraic or Amsterdam work exactly the same way.
I think that we're pretty good. We're out of time. So
Awesome.
thank you
Thank
so
you,
much,
Julian.
Julian.